Welcome to the second part of this exercise. So this time, we will train the classifiers that we built on the first part. To begin the training of our data, so let's create a new file, right-click, select new file, and then we will name this testandtrain.py. Next, we will import the necessary libraries, and then we have to create two variables that will help us to resize all the extracted handwritten characters. Just like in the first part, we'll be using the resized image width and resized image height. And then we have to load the classifiers. So we have to load it on variables. For our letter classification, we have to load it in car classification. Then let's give this a file name that we want to load, classification.txt, and then the flattened character images. And then we have to turn our classifications.txt into one-dimensional array because this is required if you're going to feed this in our algorithm, which will be the KNN or the K nearest neighbor algorithm. So let's turn this into one-dimensional array. So to do that, let's write here reshape, and then let's reshape this to 1. And then let's create now the K nearest neighbor. Let's use KNN, and then let's write here cv2 dot ml dot k nearest create, and then we have to create another one. We will call the second k nearest algorithm as k nearest equals to knn, and then let's train the data that we have loaded. So to do that, let's say knn, then let's write train, and then let's write here the sample data, which will be the flat car images, and then we have to write here the response, which will be the car classifications. Now, before we feed the second argument, let me tell you on how we arrange the data that we have created on the part 1. So the data that we have created on the part 1, the classifiers were arranged according to row. So that is why we are going to supply for the second argument as a row sample. So to do that, let's write here cv2 dot ml dot row sample. Now let's load the image that we want to test. So let's write here img test image, or let's just say test sample. And let's convert this into grayscale. So let's call the grayscale img gray. Okay, so let's apply some pre-processing here so that we'll be able to isolate those noise or remove those noise from the image. And we can do that by applying a bilateral filter. So let's start. Next is we have to get the threshold of this filtered image. So let's write here for our threshold, we will use and then th is equals to cv2 the threshold. Let's write here bf, and then let's create a copy of the threshold. So let's write here th copy. Now let's find the contours of this threshold. So let's use img contour, or let's just say contours. So after getting the contour, let's create a copy of this contour. So let's name this contour copy. The next, we have to create a string which will be used for getting the result of identifying the handwritten characters. So let's just initialize this with empty string. So now let's start iterating through the contour that we can find in the contours copy. So let's write here for C in contours copy, we have to get the box. And for us to get the box, let's write here approx. We're trying to get the approximated curve using the approx poly dp. Supplying the contour is the first argument. And then we have to multiply this with 0.01 with the arc length of our contour. And then we are only interested on the closed contour, so that is why we have to write here true. Then let's examine the points that we can get from this approx variable. If it is equals to 4, then it means that we're able to get four sides shape. So if it is a four side shape, then let's examine how large is the area, because using this one, we'll be able to retrieve even the small sizes of square or rectangle. So we have to get only those bigger ones. So for us to do that, let's write here if len of str converting the result of the CV2 that contour area using the approximated curve less than 6, then we will just pass, meaning these are small contour area. Let's write here else. That's the time we will select if it is not less than 6. So let's get the boundary of those contour using the variable x, variable y, and width and height using the CV2 dot bounding rec. And then let's draw a triangle for the selected box. Okay, so to do that, let's write here CV2 dot rectangle. Then we will write here inside of this parentheses the image where we want to write shape, and that is the test sample, and then the points where we are going to draw the rectangle. So let's write here int x and then int y. I'm sorry, I forgot to separate this with comma, then followed by, and then the color of the line. Let's write here 0 for blue, 5 for green, and 0 for red. We have to write here the int w and int h, and then this one it should be int x, and then the other one should be int y. Then the last one is the thickness of the stroke. Let's write here 2. Let's try showing the image. So let's write here cv2.imshow. So let's try running this script. Okay, so we have an error, line number 7. So np load txt classifications the text np float. Examine what is happening here. So this should be float 32. So let's try running this again. We forgot to write I classifications. And then let's try this again. Okay, we have another error. We have in line 22, it says argument image h copy. So let's check line 22. So before we go through this, let's copy and paste this code, and let's examine if we were able to load correctly the file. Let's just copy and paste this one here, and let's give this a try. Line 18, we forgot to include the name of the window. C2 not defined, line 19, okay, CV2. Okay, so we correctly loaded the test image. Okay, so let's cut this. Let's run this again. Line 22. Okay, so we forgot to include the close open parentheses. So let's run this again. Okay, so we have a different error now. It says here, line 28, Okay, so we have to write this in capital letter. So let's run this again. Okay, there you go. So it went well. So let's continue. Before that, let's try this again. I forgot to fix this. It should be plus. So let's run this again. Okay, so something is wrong. So I guess we have to review the codes that we wrote at the top. So we load the classification, we load the flat car images, and then we train those data, and then we load the test image, and then, okay, so this is the mistake. So we have to apply bilateral filter before we turn it into grayscale image. So let's write here img test sample, and this img test sample should be the bilateral filter, and then this should be the image gray. All right, so I guess that will fix the problem. Then let's try this again. Okay, so we have selected the box, another box, another box, another box. Okay, so observe that not all the boxes were selected because of some noise that we can't remove, just like those boxes with overlapping stroke. For example, this part here, we cannot select because of the noise that destroyed the stroke of this box. So again, it skipped this box because there is an overlapping stroke. So let's continue. So I'm going to comment this for now because we are already sure that our code is working well. The next is we are going to crop those box. So for that to happen, we will write here image car variable stating that we are going to create a new image out of the th copy or the th original using the int x, int y, int w, and int h. So let's write here int y plus int h, and then int x plus int w. So let's copy and paste this at the bottom, and then let's check what will be the result of having this one. Okay, so let's run this again. So instead of image sample, it should be img car. All right, so we were now able to get those boxes individually. Now the next move is to remove this border so that we can get only the characters. So let's do that. I'm going to write here car or img car equals to img car, and then we will specify the values that we want to get from this array. So we are only interested on these rows and columns. All right, so let's check this. If you were able to remove those border. Okay, so there you go. So no more borders. What we are left with here are just the handwritten characters. Then the next thing that we will do is to find the contour of these characters and then crop it again. So for us to find the contours of those characters that we have cropped, we will state here that this image should have an inverted version, and we can do that by using the CV2 bitwise and then converting it into a grayscale. Then after that, we're going to get the threshold of this inverted character So let's write here ret and th1, and then it's equals to cv2 that threshold, and then we are going to feed the img here, the img inverted, and then let's find the contour of this threshold. So let's write here cntr for contour and h for hierarchy, cv2 that find contour. And then we will iterate for each contour that we can find in the CNTR. So let's write here for my C in CNTR. Let's get the bounding rectangle by using int x, int y, int w, int h, cv2 dot bounding rec. Then let's create an image here out of the th that we created a while ago. So let's write here. So after getting this, we have now the box, but we are only interested on the handwritten characters. So that is why what we are going to do is to resize the handwritten characters uniformly so that we'll be able to compare it according to their size and according to the stroke properly using the KN algorithm. So let's write here an image variable again, but it is a resized version. So I guess we misspelled the height. So let's fix this at the top. Let's rename this to TH or HT. Then this is HT also. Okay, so that's it. And then let's run this script so that we can see if our codes are working well. So we have an error, line 41, threshold red th. So we forgot to include a comma. So we have another error, line 46. Only integer scalar arrays can be converted to scalar index. Okay, so we have an error here. Oh, we forgot it should be CV2. Then let's run this again. Okay, we forgot to change the reference image. It should be the resized image, not the image car. So let's rename this to the Roy resized. So let's run this again. Okay, there you have it. We were able to extract only the handwritten characters. But it included those erasure in the boxes, which we cannot really avoid and make a way of removing it. So anyway, let's just proceed. That will be the weakness of our algorithm. Okay, so let's just continue. Now we have to turn the resized image into a one-dimensional image because this is the requirement of the KNN algorithm. So the parameters that it accepts is only a one-dimensional array. So to do that, let's write here um, final resized, and then we will write here the resized image, and then we will call the reshape. We will reshape this into one dimension using the size of the image width and the image height. And then we have to convert this into a float of array. And then this time, let's feed this to our algorithm. So the KNN algorithm has what we call a method find nearest. So it returns four results. But what we are interested in is just the result from the second output. So let's write here retval result, then response, or just call this resp, and then distance, or let's just call this dist, and then kn or k nearest, that find nearest. So let's feed our sample, and let's just state that case equals to 1. And then let's convert the result into string so that we'll be able to print it into our screen. So to do that, let's call our str final string is equals to result. We cannot do this. It should be a, let's say, a tmp string is equals to result, and then we have to convert this into integer, and then convert this into a character, and then convert this into string, and then we have to specify the location. And then let's write here str final is equals to str final concatenated with the empty string, and then let's copy and paste this at the top, and then let's try running this application. On line 51 we have an error. Okay, so this is the mistake, so we have to turn this to float 32. So let's run this again. Okay, then let's print the result. Then let's run this again. Okay, so we have Z, and then for the first letter we have Z, and then we have B. I guess this is B. We have another B, another B, X, Z, letter C. So let's just keep on writing the letters that we see from this preview, and then later we'll compare to the printed result. So we don't know what letter is this, so I'm going to write here asterisk. So let's compare the result. So the result is, here is the result. So we have Z and then 3 B's. So we have also 3 B's. And then we have 2 Z's. The first one was identified as X, but it was identified as Z. And the next letter is C, which is correct. We have also letter C. And then we have letter Z. Okay, so let's turn this into a file. So instead of comparing our result from this printed result, let's save this into a file. So let's write here f is equals to open, and let's name the result.text, and then if it is not available, then we are going to create it. If it is already created, then it will be overwritten. Then f.write, and then we have the str final string. Then let's close the file. Okay, so let's run this again. Okay, so let's examine the result, and then let's compare it to the one that we have taken a while ago. So ZBB, 3 B's, we have 3 B's here, 3 B's, 2 Z's, and 1 C. So the X was read as Z, but the Z and C was read correctly. Then followed by Z, and at the end we have B, but it was read as Z, and we have X, but it was read as C also. So, but some portion of it was read correctly and some was read incorrectly. But at some point, we were able to get the handwritten converted into the corresponding letters of these handwritten letters. Okay, so that's all for this video, and thank you for watching.